Alright, hey guys, today we're going to be talking about reporting category number 2, graphing linear functions, equations, and inequalities. You should have this note page with you. So here we go, let's talk about it. What is the parent linear function? The parent linear function, our most basic linear function of them all, and that is the guy y equals x. Sometimes I'll tell my students to write like this. 1x plus 0. So you can see that our slope is 1, and then our y-intercept is 0. Alright, so we got that. Our y-intercept, so talking about our y-intercept, so look at this graph down over here. If I were to talk about my y-intercept as a point, it would be the point 0, -3, right? 0 and then a number. So our y-intercept is always when x is equal to 0, and we can also find our our y-intercept from if we're looking at an equation, and it's always the part without the variable. Okay. So if that said if this said 5x minus 2, then my y-intercept would be at -2. Alright, so we're good with our y-intercept, and then with our x-intercept, another word for your x-intercept, we can also call it a 0, right, where it's crossing our x-axis, and so it's similar, except it's going to be whenever y is equal to 0. So this tells me that I can plug in a 0 for y and solve to find out what x is. So we can either make a graph and look, so plug it into like y equals and go take a look, graph, or we can plug 0 in for y and then solve. Alrighty, and then the same goes for the y-intercept. You can plug in a 0 for x and it'll tell you what the y-intercept is. And the last thing, or I'm sorry, no, not last thing, but slope. Jumping over here, there's so many ways to talk about slope. So we have, first looking from something like this, where is the slope? And hopefully you said it's m. Yes, it's the m value, whatever guy's hooked up with your variable. Sometimes we'll say it's rise over run. I could do y2 minus y1 over x2 minus x1. I could call it change of y over change of x. And then the last one is rate of change. Alright, so don't forget, rate of change is just a fancy way of saying what is the slope. But do notice how all of, okay, so we have y over x, right? Over here we have y over x. Over here, whenever we're rising, it's how we move up and down, versus run is how we move left and right. So just notice that we're always talking about our y values on top of our x values whenever we're talking about slope. So it's how we move up and down the y-axis versus how we move left and right on the x-axis. Alright, so on this first example, it's talking about which equation best represents the line of this graph. Probably what I would do here is I can visually see my slope, I can visually see my y-intercept, so I'll probably go ahead and write out my equation for this. So it's going to be y equals, and if I pick out 2 points at a nice little intersection, there's some, that's showing me I rise up 3 and then I run 2. So that means my slope is 3 over 2x, and then my y-intercept is here at -3. And that's how we write the equation for lines that we're given a graph for. Y equals 3/2 x minus 3. So now, well, all of these guys are given, my answer choices are all in standard form, so I would need to rearrange each of these so that they look like this, y equals mx plus b, and see who is going to get me there. So I'll let you guys solve through those, and I'll just let you know that the answer here, whenever you solve all of these guys, you'll end up getting H. But you should, again, write these out, solve them on the side, and make sure that you're getting the same answer as me. And just real quick, you'll see whenever I solved, so I just subtracted the 3x to the other side, and then I just divided everything by -2. So remember right here, a negative divided by a negative gives us a positive 3/2, and then right here I'll get that -3. Alrighty. Alright, and now on this next one, which of the following tables best represents a linear function with a rate of change of -4/5? A linear function. Alright, so again, there's lots of options on here. Let's see, you could do like y2 minus y1 over x2 minus x1. However, that would take forever to do because you'd have to do it to each of these points to make sure that there's a constant rate. Because remember, sometimes these guys will try to trick you and they'll make like the first 2 points will be -4/5, but then maybe the last two are like they have a slope of -3 or something. So you always want to be careful and check for them. So this kind of was there's like decimals. It's not very easy for me to find what my rate of change is. So you know what I would do, since I know this is a linear function, I would use my calculator. So I'd get him out and I would plug these in the stat edit. So I'd go to stat, edit, and now I would enter in these lists. So if I look over here, I enter in my x values first: -6, -4, -2, 6, and 10. And you want to do all of these just in case they try to trick you. And then here I'll have 6.5, 4, 1.5, -8.5, and -13.5. Alright, so now I have all my tables and I'm going to double check them really quick. It looks like they're right. And now I'll go back to stat, over to calc, and I want to do the linear regression. Okay, ax plus b, which is option number 4. Click through here, enter, and let's see what it's going to give us. So looking at this, the reason why I did this is because it's going to show me what my slope is. And our slope is being given right here with the A, so -1.25. Well, it says -4/5, so maybe I don't know what -1.25 is as a fraction, so I could test it. -1.25, oops, 25, math, enter, enter, and I see that's actually -5/4, not -4/5. So he's really close, but he's not the one. So that's how I would test all of these points. So spoiler alert, I'm gonna show you the answer. So if you want to work through these on your own, just pause the video for a second and I'll tell you the answer. Alright, and one more thing that I did want to say is, notice that our rate of change is negative. If I look at my y values over here, so I can see that my y's are increasing and my x's are also increasing. That tells me that's going to be a positive rate of change. Alright, those are changing in a positive direction. And if I look over here, same goes over here. These are getting larger and so are my x's. So that's going to be a positive rate of change. So anyways, if you plug all of these things in, if you find the change between these two things, you will get -4/5. Alright, this next one is really great too. It's talking about a motorbike and it's talking about he's traveling at a constant speed. Okay. And which of the following best describes the situation or the slope of this line? So we're talking about what speed the motorcycle is traveling. So this one's kind of a good one. One, we could figure out the actual rate if we wanted to. So if I look over here at 1 hour, well, there's not actually a point for 1 hour, but I know it's going to be coming somewhere in this general direction at the very least. But if I go back and I look at my time, well, what would the time be right here where it says 1/2 hours? So that means 30 minutes, right? So if I look at where I'm at 30 minutes, well, in 30 minutes, I traveled 5 miles. Okay, so I went 5 miles in 30 minutes. Alright, so how could that translate for a full hour if I'm trying to figure out how many miles I can go in 1 hour? Well, if I went 5 miles in 30 minutes, that means in 1 hour I could go 10 miles, right? We're just doubling it. So that means this guy's going 10 miles per hour. Again, and I can double check that if I go over here. My slope is up 5/3, so if I went up another 5, that would be up at 10, and then over 3, I'd be sitting at the 1 hour mark there. So yes, 10 miles per hour, just figuring out our slope. All right, we got one more of these guys. Actually, I think we have two. Anyways, what is the 0 of f of x equals blah, blah, blah? Well, what did we just say? What is another word for 0? And yes, that's the x-intercept, okay? So if I think back about that, an x-intercept, that's going to be whenever y is equal to 0. So this tells me I can plug in a 0 for y. But I don't see a y. I just see f of x. Well, remember, f of x is just a fancy way to write y. So now after I've done this, I'm going to plug it in for y, and then I can solve for x. 8x minus 12. And I would add 12 to both sides. Add 12 to both sides. Scroll. So now I have 12 is equal to 8x. Divide both sides by 8. And let's see if we do that in our calculator. 12 divided by 8. And that is 1.5. So this is telling me that he's crossing my x-axis at the point 1.50. All right, 1.50. And I can totally double check this by plugging it into my calculator. If I go to y equals 8x minus 12 and go look at my graph, I can always double check. And sorry, I was having some computer trouble. Anywho, so looking here, yeah, 1.5 seems like a reasonable number. If I wanted to double check too, you can also still do second trace. And we want to find our 0. And so I could still kind of do the same thing that we were used to doing these with our quadratics, but you can also do them here just to double check. And it tells me it's crossing at 1.50. Cool. So we're good there. Let's check out this next one. All right, so here's the direct variation one that we were talking about in our vocabulary notes earlier. So if y varies directly with x and y is 14 when x is 6, which of the following represents the situation? All right, so I could make a table kind of, but it's saying whenever x is 6, y is equal to 14. So since it's saying that these two directly vary with each other, it's kind of like slope. I'm just going to compare my y over my x. So my y, so let's say I have y equals 14, my y value over my x value, which is 6. Does that reduce at all? And yes, it does. It reduces to 7/3, so I would have y equals 7/3 x. Okay, and so looking at these, so this is an option doing that, like comparing your y over your x, but what I could also do is just take the answer choices and I can plug in x and see if it gives me the y. So for example, on F, if I plugged in 6 here, would that y spit out 14? Well, no, it wouldn't, right? That'd be like 120. So that's going to be out of the question. Now, if I plug in 6 here for x, now watch, ready? Where's my calculator? Sorry. So if I'm here, serious computer problem. Sorry, guys. So if I do 7/3 times 6, which is my x value, you'll see it spits out 14 as my y value. Alrighty, so again, just taking the value of x, plugging it in here. 6 times 8 is 48, not 14, and that one would also not work. So we get G there. Alright. Parameter changes. Some fun things to talk about here. All right, so think about if you had a slope of 0, okay, a slope of 0, so that's like hoi. All right, that's a horizontal line, right, for 0 slope. So I want you to think, or remember slopes, the further away we get from 0, the steeper our graph is going to get, okay? So if I had like a slope of like 2/3, okay, well that's really close to 0, so it's going to be pretty flat, versus if I had a slope of like 10, that would be pretty steep, okay? So the further we get from 0, so further from 0 is going to be steeper. And then the closer to 0, the less steep our graph is going to get. All right, so again, always think about that zero slope. That's a horizontal line. So the further we're getting from that, the larger our number is going to be. Okay, the closer we get to zero, the less steep it will be. And then our y-intercept, so that talks about how we move up and down, moves up and down our y-axis. So we'll see things like if I have y-intercept at -10 and I increase it by 2 units, where will I be? Okay, so let's see one that looks like that. So in this first one, the function y equals -3x minus 8 is graphed. And it gives us a situation, some parameter changes. All right, so let's see, what do our parameter changes say? So it says if I multiply the slope by -2 and the y value of the y-intercept will increase by 2 units, what's going to be my new graph? All right, so let's look at our slope. Now, if I multiply this slope by -2, what will be my new slope? My current slope is -3, and I multiply it by -2. My new slope will be +6. All right. And then if I'm sitting here at -8, okay, I'm down here at -8 and I'm increasing by 2 units, that means I just want to move it up 2 units. Where will I be now? And hopefully you're saying -6. All right, so which graph looks like that? Well, first I have a positive slope, right? Positive slope. So I'm going to eliminate F and G because those are both negative slope. Now, who's intercepting at -6 on my y-axis? And that is J. Awesome. All right, so those are the kind of parameter changes you might be seeing. One last parameter change that you might see, or question kind of like this, is comparing two different graphs. So this is an easy one. If I'm given two functions, I can just go plug them into my calculator and see what they're going to look like. However, we should also be able to recognize like the difference between our slopes right now and our y-intercepts, right? So who has the steeper slope? Well, remember, the closer you are to 0, the less steep you're going to be. So who's going to be steeper? Well, 1/2 is closer to 0, so he's going to be less steep versus this guy. He's going to be a little bit steeper, so we can know that. He's going to be a little bit steeper. And who has the taller y-intercept? Okay, well, this guy's crossing at 8. This one's at 2, so he's going to be a little bit taller on our y-intercept. All right, so again, ultimately, you just want to plug these into your calculator to see what's going on. But right here, I want to show you a really quick little thing. We haven't talked about it a lot in class because we were unsure what kind of calculators you'd be given on the test. So most of the calculators that we have in our classroom can perform this function, and we just found out that on the STAAR test, every calculator will perform this function. So if you don't know about the alpha F1 already, then go ahead and pay attention real quick. So I have a fraction for my slope right here. I could do it the classical, like 1 divided by 2. I could totally do that, but I want to show you something new. If you click your alpha button, the green one, so alpha F1, where your y equals is, alpha F1, you'll see you get this little thing. And I can turn this into a fraction by clicking this first option, so I'm just going to hit enter. And you'll see it gives me like a little fraction bar. So I can click 1, down, over 2. Now to get out of this, you have to click the right arrow key, and then I can put my x plus 2. So now it looks exactly how it appears on my paper. So again, alpha F1 if you're unsure about that. Now I'm just going to go look at my graph. So the blue one is f of x, and the red one is going to be g of x. So let's talk about these two things and look at our answer choices. So the graph of f of x is below g of x. All right, that's talking about our y-axis, so no. Here's f of x, here's g of x. F of x is clearly above g of x, so he's gone. And looking back, now the graph of g of x is 6 units above f of x. So that's actually saying the same thing, right? It's saying that g of x is 6 above f of x, which is not correct again. So eliminating answers. Now, the graph of f of x is steeper than g of x. I would have to agree. If we look at the blue line, he is steeper versus the red one who's not quite as steep. So we're going to go see here. All right, correlation, scatter plots. Scatter plots. So we do need to talk about a couple things here with our scatter plots. We have 3 types of trends, if you remember. One of them is going to be if we have a positive trend. It's going to look something like this. If all of our points are moving generally in the positive direction, this is positive. All right, then we have a negative trend if it looks like this. All right, this is a negative trend. And then there's one more, or correlation, trend or correlation. There's one more. Which one is it? And hopefully you remembered, that is when there's no correlation. If I just have points all over the place, there's going to be no correlation or none. Okay, no correlation or none. Positive, negative, and none. All right, cool. So the next thing that we need to talk about is this correlation coefficient, okay? So it's been a hot minute since we got to talk about all of this stuff. So you'll definitely need your graphing calculator, and you have to remember how to do these things on your own, okay? The teacher in your STAAR testing room will not be able to remind you how to do this, and probably he or she will probably not even know what you're talking about. So anyways, to do the correlate, okay, so if you remember, this is the R value. Whenever we find like our line of best fit, it tells us the strength of our scatter plot. Remember, the stronger, so this would be like a really strong scatter plot where the points are very close, versus one like this where they're both positive, but you can see the difference. One is tighter, a little bit tighter, the other one's a little bit looser. So the stronger it is, the tighter your points will be. So again, you have to remember how to do this. If you get your calculator, you have to go to second zero, okay? Second zero, that gives us the catalog function, and then you have to scroll all the way down until it says diagnostic on, and then you'll hit enter twice whenever it says done. All right, I'm not going to scroll all the way there right now because it takes forever to do it on the computer calculator. However, if you just scroll down again to diagnostic on and hit enter, it'll say done, and that tells you that you turned it on, okay? So you have to remember that. You can write this down if you need to. So second zero diag on. All right, diagnostic on. And again, so remember, the closer it is to 1 or negative 1, the stronger he is. And then the closer to 0, the weaker he is. All right, so if I had an R value of like 0.995, well, that's very strong. He's very close to 1. Versus if I had an R value of like 0.23, like that's pretty weak. Now, do also note that it will, for a scatter plot, your R value will never actually be 1. It could be very, very close, like I said, like 0.998 or 0.995, but it will never be a perfect 1. In order for him to be a perfect 1, it would have to be like this, which is essentially a straight line. All right, so it might be, again, very, very close, but never a perfect 1 for scatter plots. That would be linear. So looking at this first example for the graph to the right, what would be the correlation coefficient? Well, first, what kind of correlation do we see here? Positive, negative, or none? And hopefully you're saying it's positive. Yes, this is positive correlation. Just a fun fact side note. So since it's positive, I can actually eliminate my negative answer choices. So now I'm left between 1 and 0.7. Well, remember the conversation I just had. It'll never be a perfect 1 unless it's a straight line, okay? It just points that form a straight line. So he's not super tight. He's close though. So we'll have, well, is it B or is it B? Obviously there's a typo here. Anyways, 0.7 would be the better fit for this particular problem. Again, it'll never be a perfect 1. All right, last thing to talk about is these inequalities. So remember, if, let's see. So if it looks like this, if we have this, it's going to be a solid line, and we're going to shade above the solid line, okay? If it's greater than or equal to. If it is less than or equal to, it's also going to be a solid line, but we will shade below on our graph. If we have just greater than, it's going to be a dashed line, and greater than we shade above, and if it's less than, it's going to be a dashed line, and we're going to shade below the line. All right, so write that however you need to write it. And then the most important rule is when multiplying or dividing by a negative, what do we have to remember? We need to flip that sign. Alright, so flip your sign if and only if you multiply or divide by a negative. Usually that'll be in your last step. If you had like negative 2y is less than blah blah blah, then we would divide by negative 2 and then therefore reverse the inequality sign. Also make one last note somewhere that says, think about where are the solutions for inequalities. Okay, where are solutions for inequalities? Well, why do we shade these things to begin with? Well, that's because that's where all of our solutions are. That's our solution set. So solutions are in the shaded region. All right, so what I mean by that is if I had a graph and it was like this and I was shaded below, that means all of my solutions will be anywhere in here in the solid region, or in the shaded region, I'm sorry. All right, so let's look at this first example. Which graph best represents this? Well, I can't do anything with this until I get it into a y equals mx plus b format. So I'm going to solve for y by subtracting x to both sides. I have 2y is less than negative x minus 14. Divide everything by 2. Do I need to reverse my inequality here? No, because I divided by a positive 2 and not a negative 2. All right, so I have y is less than negative 1/2 minus 7, and I'll just rewrite that. Y is less than negative 1/2 x minus 7. All right, so I have a negative slope, so I can eliminate this one and this one because both of those are positive slope. And really without anything else, is it going to be a solid line or a dashed line? Solid or dashed? Well, looking here, since it has the equal to sign, that tells me it's going to be a solid line. So J is my answer. And then it's less than, so I will shade below. So I could get any of these solutions in here. All right. Now sometimes you have to write these inequalities, so we just want to be careful with the wording. Wanda wants to buy some picture frames. They're small ones for $8, large ones for $12. She wants to spend less than $100. Okay, so we need to write this out. So it costs $8 for a small frame plus $12 for a large frame, and we want to spend less than 100. Okay, I don't want to put the equal to sign because it doesn't say she wants to spend $100. It says she wants to spend less than $100. So we see that B is the best answer choice there. And on this last one right here, which coordinate pair is in the solution set? Now remember, to be in the solution set, he would need to be in the shaded region. So you are going to be given graphing paper on your STAAR test. If I were you, I'd probably literally go and graph it just because that's my personality. However, we also have other options. Remember, these are x and y points. So this is the point x, y. And what I can do is plug those in. And if I plug it in, what am I going to be looking for? Okay, and I tell my students we're looking for a true statement. All right, so let's see what that looks like. I'm going to pause for a second and plug in x and y and then solve. All right, so I finished solving it over here by plugging in x and y. So when I did the math, so right here I get to this last statement, is 3 less than negative 3? Well, no, right? It's equal to. If it had the equal to sign, that would be cool, but it doesn't. So no, that's not a true statement. Therefore, that would tell me to go try out another answer. So you could do all of this, plug in your x and y for each of these different things. And I believe once you do that, the only one that'll end up making sense or giving you a true statement will be B. All right, so plug those x and y values in. Make sure that you're getting the same answer as me. Best of luck on these some of these problems. Hopefully these are some of the easier ones too that'll count towards your magic number, that number that you're trying to get, so that way you know that you're passing the test. Y'all are going to do just fine. Good luck.